accurately. They're not your easiest kind because they do require calculation, although they are used a lot because they give the person a sense of there's a 100% going on. They're also a frequently misused way of representing data because they don't always make the space representative of how much of the circle it should be taking up. I have seen them, for example, take something that should only be 25% of the data and give it like a third of the circle. That shouldn't be the case, all right? If it's 25% of the data, it should have only been a quarter of the circle. So this one is probably the most misused, but we'll talk more about that when we get to the work. Okay, for in here, here's what I want you to learn to do, and that is be able to find accurately the number of degrees that you should be allocating for each category of information that we have. So I'm taking the same information that I had from the M&M survey in the above bar graph, and we're now going to put that same information into a circle graph. Now I didn't warn you to bring protractors. If you brought a protractor just because you carry one around in your book bag, good for you. You'll be able to follow along with me. If not, then once I get it up on the board, just make a sketch on your paper, knowing that if you wanted to accurately give a circle graph, you really do need to pick up that protractor and use it. Okay? All right, here we go. First, we got to take this chart of information that we have. So let me recreate it up here on the board. I'm hoping after the last chapters that we've covered that this is a nice chapter to end on. Relax a little bit. Okay, now the whole point of this chart is that we need to know that when we say 15 people said they like red M&Ms the best, what portion of a circle does that need to represent? Or when I start making that circle, how many degrees of that circle? Knowing there's 360 degrees total in the circle, okay? So first of all, how many people do you have in this survey? What's the N value?
65.
65?
I think. I bring a chick next to me. I don't know how to add. You pregnant people, why don't you know how to add?
Okay, now we're going to find the percentage for each category. So quickly, it doesn't say on your paper, but how do you find the percentage that like red M&Ms?
Frequency divided by the total amount.
Right, frequency divided by total. And then give it to me in percentage form. So what's 14 divided by 65? 22% liked red. What percentage liked blue?
23.
23. What percentage liked green? Yep. What percentage liked brown?
8.
Orange? 20. And yellow?
11.
Okay, and again, we got those just by dividing frequency divided by the total number. Okay, I need those percentages because as I draw the circle graph later, I'm going to, in each section, write the color and percentage in each section of the circle graph. Okay, but still I don't have the information that I need for how many degrees of the circle each color should be. Well, you know that there's 360 degrees total. You know the percentage of the total that should be that color. So you're going to take the percentage of each color times the total number of degrees in a circle. And that'll tell you how many degrees should be each one of the colors. Just to make sure when you multiply that your percent is in decimal form. So you're going to be taking 0.22 times 360 and 0.23 times 360. And that'll give you the number of degrees. Just round it to the nearest whole number. Okay? Which means at the end you're going to have an approximate 100% total. Sometimes it'll be like 99.5 or 101. But as long as it's close and you know that's just because of rounding. Okay, so if you take 0.22 times 360, what do you get?
79.
Okay, if you take 0.23 times 360, what do you get? 0.17.
61.
Remember, these are degrees of the circle. 0.8.
29.
0.20.
72.
And 0.11. Okay, now if you were to add those up, they probably do not total 100%. But it should be fairly close. Like you shouldn't be coming up with 120% there. Okay, just for the sake of making this easy, I'm going to make my circle the exact size of my protractor. You can feel free to do the same thing. It makes marking off the what you need just a little bit easier. Or you can get out a compass and use it. Either one works fine. Now this also gives me, I can quickly find where the center of my circle is at, my protractor. I'm going to start out measuring from that line. Okay, then we're going to measure out 79 degrees, and that will be red. I'm going to go on the protractor real close to 80. Notice it's 0 right here and measure around. I'm not going to spend a lot of class time on how to read a protractor. That's for the T103 class. Okay, so this category right here is red, and that is 22% of the data.
I know you just said something about the T103 class. Do you teach that?
I might in the fall, we don't know yet. I just talked about it. This summer, no, well, Scott's teaching it this summer. Okay, blue, 83 degrees. Now, we've got to turn this protractor right here, put this as your starting point as 0, and then measure around 83. So a little past 80, but not quite to 85, somewhere right there. And then draw this line. Okay, that category is for blue. And it should look like it's about the same size as the red. It's only 1% different. So it should look like that. Although that's probably the one that people would intentionally make that one bigger and make the red and orange smaller, because they were trying to show a big emphasis on blue being the largest value. And it's like, well, hello, one extra person likes blue. Had you asked me instead of the other person, it may have changed it. I don't know. Actually, it would have kept it like this. Green, 61. So we're going to put the protractor here. That was our last stopping point. Now, this is our 0 line measuring around 61. Puts us right about there. And again, you're not seeing a huge difference in the category. This one is green. And that is 17%, which visually on a circle grid graph isn't a difference because really there isn't a large difference in those colors. Okay, brown.